Hi guys, and welcome to the video on similarity. Just a couple real quick things. This is going to be a quick video. If you guys look at your notes, it basically says that two figures are similar if they have the same shape but not necessarily the same size. First of all, I want to talk about what the symbol for similar is. Okay, so if I'm saying that things are similar, basically the symbol is this. Okay, so things are similar if they have the same shape but not necessarily the same size. So a good example of that would be a square. Okay, so if I have a square here, pretend that's a square. Okay, and I'm going to draw another square that's bigger. Alright, so those are similar if they're the same shape but not necessarily the same size. If you notice, they are the same shape, they're both squares. Okay, because they're both squares, they both have 90-degree angles for all four of their angles, so all of the angles are congruent. Now obviously the sides are not the same, so in order for them to be similar, the sides have to be proportional. Now in squares, all squares are always similar because the definition of a square is that all sides are congruent. So if this side's 4, obviously that side has to be 4, and that side has to be 4. So when you multiply it by a scale factor to make it bigger or smaller, no matter what that second side is, whether or not it's, let's say it's 15, then they're all going to be 15. So this is a similar shape. Really what we're going to be talking about for the most part is talking about similar triangles. Okay, so in the notes it talks about you having this statement. So triangle ABC is similar to triangle XYZ. Okay, remember this statement right here, this similar statement is saying that all angles are congruent, okay, and the sides are proportional. Okay, so looking at the example that it has, alright, so we have got triangle ABC, and then this one, if you notice, they're not shaped, or they're not positioned the same way. EDF. Alright, so it's got a couple of things on here. First of all, it's telling you that A is congruent to D, and it's also telling you that E is congruent to B. Okay, now if you think about it, if it's a triangle, if two angles are congruent, then that means that this third angle also has to be congruent. Okay, so we've got this side at 16, 24, and 20, and we've got 18, 12, and 15. Okay, so we know that the angles are congruent. So now we need to see if the sides are congruent, or not congruent, but proportional. So let's see. We have got AC over here, which is this one. AC corresponds to DF. So AC is 16 over 12. Okay? And let's see. CB corresponds to ED. So 24 over, I'm going to move that over, 24 over 15. Right, and then our last side, AB over here corresponds to EF. So I've got 20 over 18. Alright, now if this is proportional, that means that all of these side lengths are going to simplify to the same ratio. So this would be 4 over 3. Right, this one would also be, alright, hold on, I made a mistake here. This one should be 18, and this one should be 15. Alright, so now we're going to go ahead and simplify. So 24 over 18 simplifies to, let's see, 4/3, and 20 over 15 simplifies to 4/3. Okay, so my mistake was that the 24 goes to this side and the 20 goes to this side. right, so if you notice, they all simplified to 4/3. So that means that those side lengths are proportional. Okay, so remember, angles have to be congruent and side lengths have to be proportional. All right, so now let's talk about proving triangles similar. You can prove that triangles are similar in 3 different ways. The first way is that, excuse me, if 2 triangles have 2 congruent angles, so it's called AA similarity. If they have 2 congruent angles, then they are similar. Okay, the second way is if they have 3 sides that are proportional. Then that means that it's side, side, side proportionality. So that is 3 sides proportional. All right, and then the third one is side, angle, side similarity. Okay, that means that 2 sides and the angle between. All right, so let's talk about that a little bit. All right, so this first one, we have got 2 triangles. And if you notice, it only has the side lengths. So basically what we're trying to do is figure out if this is similar. So if you have 3 sides of a triangle and they are all proportional, that means that the triangles are similar. So let's go ahead and look. You notice that this is an isosceles triangle and this is an isosceles triangle. So obviously the 2 and the 3 correspond. So we're going to do 2 to 3. All right, the other ones are 3 to 4.5, so we're going to compare 3 to 4.5 and 3 to 4.5. Okay, so basically these have all got to be at the same scale factor in order for it to be similar. All right, and if you simplify all these, you get for each one 0.66 repeating, 0.66 repeating, and 0.66 repeating. So basically that means that you can say that triangle PRQ is similar to triangle SUT by side, side, side similarity. Okay? Because you have two triangles that have all 3 sides proportional to each other. All right, let's look at the next one. All right, so here we have triangle PEF, and here we have triangle HJK. All right, so let's notice a couple things. First of all, they both have an angle of 70, okay, that is congruent. And then we've got 2 side lengths. So let's talk about which ones correspond with which. These 2 right here are both our hypotenuse. So we're going to compare those. So we're going to do 2.9 is compared to 5.8. Okay, we're going to compare the hypotenuse of the smaller triangle to the hypotenuse of the bigger triangle. All right, and then we're going to compare this 1 to 2 because we're going to compare this side to this side. So we're going to have 1 to 2. Okay, so you can check to see if they're proportional by just doing cross products. So 2.9 times 2 is equal to 5.8, and 1 times 5.8 is equal to 5.8. I lost my, this should be 5.8. All right, so you can say that triangle PEF is similar to triangle HJH because of side, angle, side similarity, because there's a side, right, this angle, and this side, right, those 2 sides are proportional to these, and these angles are congruent. Okay, last one. Okay, well this one doesn't have any kind of side lengths, but if you look at it, we know a couple things. First of all, we've got a 90-degree angle and a 90-degree angle. So first of all, let's do our triangle. So this is triangle BAC, and this one over here is triangle EDC. All right, so we've already done side, 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 angle, side. The only one that we have left is angle, angle. Because remember, if you have a triangle that has two congruent angles, that third one by definition has to be congruent. So let's look. We've got 90 degrees and 90 degrees. So obviously those are congruent, so we have one angle. And then you've got this vertical angle right here. That means that these two are congruent as well. So that's our other angle. And remember, by default, if these two angles are congruent, then these two have to be congruent as well. Okay, so if you've got three congruent angles, then you can say that the triangles are similar by angle, angle, similarity. Okay guys, it's not real. All we're doing is talking about similarity, so that means that all angles have to be congruent and sides are proportional. And that's for any polygon, not just triangles, right? So that's basically the part that you all did in 6th grade. But now we're talking about the similarity theorems, which is angle, angle, similarity, right? Both angles are congruent. The other one is side, angle, side similarity, which means that two sides are proportional and they have one angle that is congruent. And the other one is side, side, side similarity. So that just means that all three sides of both triangles are proportional to each other. Okay? So just remember angle, angle, side, and side, side, side. All right, so you're going to go ahead and complete the worksheet to get some practice, and you guys have a great day. Thanks. Bye.